When humans leave footprints on the surface of the moon, they last basically forever. That's because there's no wind or liquid water to erode away the boot prints from the lunar sand. The last time humans set foot on the moon was 50 years ago. But that might change in the coming years, thanks to collaborations between government agencies like NASA and the private space industry.
Hi, I'm Madeline from Wanda, and today I'm talking with someone who works in the space industry named Wanda Sigur. Ms. Sigur is an aerospace consultant for companies that work on space exploration, working on everything from weather satellites to space telescopes to spacecraft that orbit Mars. Thanks so much for talking with us today.
Pleasure's mine.
There are so many exciting things that are going on in the space industry, but one project I've been hearing about a lot recently is the Artemis program. What's the goal of the Artemis mission?
Well, that's a great question, and I'm glad you're excited. I'm excited as well. So the Artemis mission, or rather Artemis program, are a series of missions that are being developed by NASA. And I've got to say, what the Artemis program is doing is bringing the magic of deep space exploration to our generation. As you know, we went to the moon 50 years ago, and over the last few years, we've been celebrating a number of those key milestones. But over 50 years, we have learned a lot. So, for example, International Space Station, we've had a human presence in space for 22 plus years, if you can believe that. So wow. We have learned what it's like to have people in space. We've learned a lot about space. We've learned a lot about deep space with respect to planets. We've learned about the moon. We've learned about the structures there. We've learned how much we can find out about about Earth itself through looking at these other places. So the Artemis missions are planned to take those stepping stones so that we're able to get smarter and more capable and competent and put feet back on the moon, put footsteps back on the moon and make footprints, right? So with that, Artemis 1, which, if you can believe it, we launched it middle of November 16th. It just landed this past Sunday. It was an uncrewed mission, which let us learn a lot about the vehicles that we're using. Artemis 2, which will follow probably in a couple of years, will be a crewed mission, which will go further into space than people have ever been. Artemis 3 will actually land on the moon. So with that, we've got 3 missions that are planned and a vision for at least 10 more beyond that.
I completely agree. It's such an inspirational story to look at the moon and think about all of the work and the thousands of people it took to get us there. I love thinking about how many people worked together to make that happen. How long does it take to get a rocket ship to the moon?
Yeah, that's a good question. And probably the short answer is about 3 days, right? So the Apollo missions, when you have people on the rocket ship, it's going to take you around 3 days. But as you can imagine, it's not a straight line, of course, right? So as you consider orbits, it could take less or more. If you're going to stop with the moon, it's going to take a little bit longer than if you're just going to fly by. So for example, and it depends on how heavy you are, right? If you ask me how long it would take for me to get from my home to the store, depending whether I took a bicycle or I took a car, the answer would be different, right? So if you're looking at rocket ships, you see that same type of difference in answer. So it's about 3 days for a manned mission or a crewed mission. And I'd say the fastest spacecraft that we've had was the New Horizons spacecraft. Do you remember the mission we just completed a couple of years ago to Pluto? So that was one of the fastest takeoffs in rockets. That went over 36,000 miles an hour. It passed the moon in about 8 hours. So again, it matters. It's how close you are. It matters where you're going, whether you stop, and how big the rocket power is compared to your spacecraft.
So I want to go back to, you mentioned the various stages of the Artemis program, and you said that the first Artemis mission that just launched recently was unmanned. So that means that there were no astronauts on board the rocket?
Yes, that's true. So the very first mission was for us to get smart about the various components that were part of the Artemis stack. The intention was for us to learn about that system and also learn a little bit more about the moon. So there were some experiments on board that gave us information about potential future missions. But we also wanted to understand a bit about the environment in which we're going to put astronauts in the future. So even though there weren't any people on this mission, we did have 3 mannequins. They called them moonikins. which let us get smarter about a couple of things. One, the new spacesuits that have been designed for astronauts for the future, and a special vest that's been developed by the United States, Israel, and Germany called the AstroRad vest, where we had one of the moonikins wearing it with sensors in various places to learn about the doses of radiation that you would get, and perhaps areas which are more sensitive than others. And then we have one without. So we were able to get information and data about radiation in a number of ways that would help us inform our next missions going forward with people on board.
You said that it takes about 3 days to get to the moon, but eventually we want to send people to Mars. How long would it take to get to Mars?
So that also depends, right? So let me kind of give things a little bit of a context. So if you can imagine, the Earth was the size of a globe. Remember those globes that you had in school that you'd sit on a desk? It was roughly about 3 feet in diameter. It had all the continents on it. And you could pretty much get a good feel for where things were on Earth. Well, if you can imagine, Earth really were that size. If you were going to the moon with that scale, the moon would be about maybe half a block away, 50 yards, just at that scale. So the moon would be half a block away. Mars would be 10 miles away. So it's 200 times or more further away than the moon is from Earth. So generally, the estimate is it would take about 9 months to get to Mars from Earth. Because we're considering that these are planet bodies around the sun, they have to be aligned so that they're relatively close to each other, right? You want to make sure that they're both on the same side of the sun, for example. And as you consider the orbit of these bodies around the sun, you need to make sure that everything becomes in phase. So if you were going to make a round trip, you would have to wait 3 months at Mars so that things would be best aligned for you to come back in the shortest period of time. So that whole round trip would take about 21 months. So it's quite a bit longer than a few days, right?
Absolutely. Do you think that eventually there will be like a base on Mars or on the moon? Is that part of the plan where that people can live there?
So I should probably share a little bit about where NASA's vision is for exploring the moon. What's different about the Artemis missions, as I mentioned, we're going to take it from 50 years ago and something that feels contemporary, is that rather than it being a series of short missions, the plan for us this time around is that we're going to stay. So with partners, there's going to be something that's going to have longevity. We're going to have commercial partners, people doing science and staying longer. So there is a plan for there to be a gateway, is what they're calling it, which is pretty much a small lunar station right around the moon, where folks can fly from Earth to the gateway and work there, and then visit the surface of the moon. So there will be a moon base. There will be something on the surface of the moon that will allow folks to perform science and gradually build out capabilities, right? I would envision that as you'd consider going to Mars, that would also make sense. It's a lot easier to launch out of a smaller gravity well or a smaller structure than a larger one, right? So it's easier for you to launch from a small station rather than from a large planet. So I would envision that might be part of a plan that we consider as we go forward to Mars. As we're considering having something that's in orbit around the moon, we probably would also want to consider having something in orbit around Mars when we get our head around those particular challenges.
So probably the Mars base is much farther off than a moon base, but do you think a moon base could happen in the lives of our audience, the people watching this video? Do you think that's something that they could see?
I certainly hope so. Well, that's definitely within the 10-year plan for NASA, right? So as we're considering the Artemis build out and landing on the surface of the moon, absolutely, we should expect to see the gateway. We should expect to see that build out with modules that allow astronauts to stay there for 10 to 30 days. We should expect to see probably within the next 10 years or so capability on the surface as well. There is a very aggressive program assessing small landers as well as human landers for the surface of the moon.
Wow. So I'm thinking about how far these rockets have to travel to go to the moon and then come back. And you said that takes 3 days just to get there. And that's the simple answer. And surely they have to carry a lot of weight. And you said that has a lot to do with how fast it can travel, because they're carrying materials up to the moon. They have to carry their own fuel and everything, right? So how important is it to make a rocket ship as light as possible? And how do you make that happen?
Wow. So sure, that's a great question. So let me, I guess, start with an example of how important mass is. So mass and inertia and gravity are probably some of the most important elements to consider when you're trying to launch something into space. If we consider an example that's typically used, if we consider just going flat on the ground as a way to get our head around the idea of how important mass could be, if you're pushing a person who's heavier than someone else, right, it would take a whole lot more energy to get them going at a certain speed. If you've got a small car or a large car and you're the person pushing it, it would take you a whole lot more energy to move someone, to move the heavier car. Now, imagine if instead those cars were being launched vertically. You all also need to consider not just the mass, but the fact that because there's more mass, gravity is going to pull on it more. So there is very much a consideration of the mass of our payloads of the rocket and the fuel itself as we're trying to reach orbit. So we spend a lot of time trying to figure out what the right designs are, what the engine configurations are, because they make a big difference in how fast it can go, and what the propellants and overall rocket configuration is, because that can provide the energy that allows for us to send the mass into space.
This has been so interesting. It's been very cool to learn about Artemis and all of the plans that we have for exploration in the next 10, 15, 20 years. So thank you for sharing about all of that. And I'm curious to hear more about how you got there and how you got to where you are today. Could you tell us where you grew up?
Sure. I grew up in New Orleans, Louisiana, which is a very unique place, and had the opportunity to spend a big portion of my career there. What's interesting about New Orleans is that it's a port city. And as such, it's a great place to make really big rocket systems, because you can take advantage of the waterways and ship these big rocket systems down to Kennedy Space Center in Florida. So we're able to take advantage of that. And that turned out to be fortuitous for me, because I was a space geek from a little bitty girl. I was one of those kids that had a mobile of the planets over my bed and a huge map of the moon on one wall. And I, from very little, wanted to either be a space scientist or an astronaut. And I was very fortunate to find out that I was pretty good at math and physics and was excited by it. And someone suggested, well, maybe you should be an engineer. And with that, I followed that lead and went to a school in Houston at Rice University, and had a professor there who was also a space geek. So he helped me get my first internship. And that was at Lockheed Martin. And I was able to continue working there and on harder and more exciting programs throughout my career.
Wow. So you really always knew that that was what you wanted to do.
Absolutely. And I've been so fortunate in having the opportunity to do what, as a little girl, I envisioned I could.
That's awesome. Do you have any advice for young people who are also interested in space or thinking about a similar path as yours?
Well, sure. I have a very strong conviction that as space is more than just a series of programs that really smart folks get to do. And, there are only 600 people that actually been to space, right? There are opportunities out there that I think will include more of us. It will be a broader umbrella. So when we talk about space anymore, it'll be more than just the kid who likes math and physics. It'll be someone who wants to understand what people are interested in. It'll be someone who wants to understand the psychology of being in a spaceship for 9 months. So it's really all the science, technology, engineering, and math fields. So it's a broader template for success or engagement that I would share. Well, one is I think it's important to remember that you got to stay in school. So that might it might be something you wouldn't necessarily think you have to say, but whatever your passion is, there is someone, there is a field, there is a school, there is a place where you can learn more about that thing that drives you. So stay in school, stay involved, graduate, consider where you want to go, think about the next steps of education and how it can make a difference in your life.
I love the message that space is big enough for all of us and that it's going to take all of us to really get there and achieve all that we can in space exploration. That's such a powerful message. Thank you so much for talking with us today. Our conversation has me so excited about the future of space exploration and the space industry. I can't wait until the day that I look up at the moon and know that there are astronauts up there and scientists working and studying and learning more about our amazing universe. This is so cool. It's been a pleasure to learn about it from you.
Pleasure's been mine. It's been great talking to you.